Hi, this is Mike Hendrickson from Solid 2015 in San Francisco. I'm here with Mickey McManus. Mickey, how you doing?
I'm doing really well.
So you have a unique position at Autodesk. Can you tell us a little bit about what you do?
You bet, yeah. So I'm a visiting research fellow in the office of the CTO. So one of the sort of cultural approaches that Autodesk takes is it really likes to engage with extreme users, people who are really pushing on the edges and exploring farther, like over the next horizon. And a few years ago, I wrote a book called Trillions, which was about a world saturated with computing. So what happens when we have trillions of things sending billions of messages, turning into bricks, getting bad updates, et cetera? And what are the potentials for business and society? And Autodesk heard that I was going on sabbatical and said, we like engaging with extreme users. Why don't you hang out in the office of the CTO? And the office of the CTO sort of does three things, which I think are useful to understand. One is explore caves that maybe nobody's wandered into yet, find interesting rocks and figure out how to exploit them, and then come on back and explain them, to ourselves and to our customers and things like that.
Yeah. So is there an answer to Trillions? I mean, what, if I didn't have to read the book, what would be
well, I think the gist of the book is that we are probably 5 years away from trillions of computing devices, and that wouldn't be bad, but then imagine a world saturated with computers. It's almost like a super saturated solution. They're not all connected, so maybe we could cope with that. But concurrently, connectivity is joining Moore's Law. There are people like Intel working on Moore's Law radio that basically puts all the parts of a radio on silicon, which means that suddenly the cost of connectivity drops to dirt, to nothing, to dust. And so we'll have this super saturated solution where that seed hits it, and we're going to turn the sock inside out. We're going to go from information in computers, if they're like your supercomputer in your pocket, to us being surrounded by information. So I think the history books are going to call it an era of, the next information age will be an era of unbounded malignant complexity, because there's a lot of stuff.
Unbounded malignant complexity.
Yes, we have to get ready for that, and it's
so
5 years away.
How do we get ready for that? I mean, how do you handle the complexity of trillions of things?
Well, I think we're here at Solid, and a lot of the conversation is around the Internet of Things, and that's pretty exciting. But I would posit that most people are not treating it like it's real, like they're doing the Internet of Thing, or maybe the Internet of Five Things, or the Internet of My Things.
My device.
Yeah, and they're going to make you be the connectivity, you the normal user. And so in an era of unbounded malignant complexity, how do we cope? And there's going to be a bubble. There almost always is. There was back in Holland in the 1600s over tulips. There will be one in the Internet of Things. But trillions is a really big mountain. Anything multiplied by a trillion is kind of interesting. And we just hit like 8 billion cell phones. That's our supercomputer world. This is much bigger. And so a wise man told me, if you want to figure out something really complicated and different, then go find somebody who's already done it. And it turns out nature's been doing this for 3 billion years. Your body's a complicated information system in its own right. You're going to go 80, 90, 100 years without a catastrophic failure. So there are a whole bunch of patterns like biomimicry for information systems that we can look at. And so I think the answer to how we're going to cope is we're going to have a bubble. Two kinds of people make it through a bubble: lucky and smart. It's the same people who make it through Vegas.
Wow.
Okay. You either pull the lever. I can't help people that are lucky. I just can't. So we wrote Trillions, and my research, which is sort of into a little bit of my part of the sequel of Trillions, is really about how will we cope, how will we thrive in this kind of an ecology. And that's for the smart people. I can't help the lucky people, but the smart ones, I can sort of figure out how to count cards. And one of the ways we can count cards is go look at beautiful complexity, which you can find in nature.
So beautiful complexity in environment of machines.
Yeah.
And machines everywhere.
Yeah, so I'll give you one example. Pando. Have you ever heard of Pando?
No.
So Pando's a stand of quaking aspen in Utah that's been running for 75,000 years. And it is one organism. It's a clone. It shoots a shoot across under the earth, and then it shoots up another tree. And it's done this. So it's one organism, but it's got a whole bunch of friends. And so it uses this trick that nature found called mycorrhizal networks. Myco is just fungus, and rhizal is kind of horizontal. And if you look just a few inches below the surface, you'll see this fungal network that's actually taking carbon atoms from dying oak and moving it over to Pando. You'll see this network basically grabbing water from areas of abundance and moving it miles to areas of drought. When the leaves change, they all change at the same time over acres, because it's one organism. So this is the social network of plants. And it's actually very common. It's mutualism. It's good for me, good for you. And I think that's one of the patterns that we have to start understanding, is being a part of the flow and not the other kind of symbiosis, like parasitism, but really, how do we play together nicely? So that's one of many patterns we can find in nature.
So it seems like that maybe in the future that we're looking at other disciplines informing us, like anthropology, perhaps, and other things that are much more than just the machine orientation that we're all looking at right now.
Well, I do think, I think it would be a real shame if we forced ourselves to meet computers halfway. Like, everyone wants to teach everybody to code. We should all code and all that. And it sounds like a bunch of Lionel trained hobbyists from when I was a kid going, everybody should learn that this thing needs to be glued down over there. No, I'd like maybe computers to bend to my will. I'd like it to be human-centered. Because in an era of unbounded malignant complexity, the companies, the businesses, the industries that actually pay attention to people are going to win. And so how do we tame that complexity but give us the power that complexity brings? And I think that's part of the challenge. And I said it's going to be this massive thing. Well, nature has this thing called an ecology. And in an ecology, you figure out there are organisms. It's actually a market economy. It's almost always on the edge of chaos. Independent agents can harvest unused resources. That's entrepreneurship. That means our things might actually have something like a distributed blockchain or currency of some sort, So there are a lot of patterns we can look at. Your body's mostly peer-to-peer, right? Your memory is so cheap in nature that if you cut your leg, all the buddies around it fix it. It never calls the cloud. Every single cell has an extra copy of you. And so that's a pattern we can do. So there are a lot of those kinds of patterns, and I think it's more about how do we design for ecologies. And that's just a very different world, because
human ecologies.
For human machine combined ecologies, because I think we're both life forms in this space. So symbiotic, mutualistic, and that means you have to study some other tricks like generativity. It's like you paint down a few parking stripes and lines in the parking lot, and then stuff emerges, and then you become a gardener. So I think designers, business people, engineers, we're all going to have to shift from designing for complete control to designing for a little loss of control, and becoming more of a gardener to sort of pull out the weeds and turn the wildflowers to the sun, and sort of really realize that feedback loops and cybernetics and all the things that have to do with ecologies and complex connected systems are an entirely new set of business and design skills.
So as we hurl down this highway trying to train machines to think and to adapt, is that a good thing that's happening, or are we going to come to a tipping point or a tip-over point, or whatever we're going to call it?
So in Trillions, we put all the bad news in chapter 3. we said like, drink hemlock, have a pity party, cry yourself to sleep. Here's the bad news, because there's some not great news. Some of the stuff we're doing today, relational databases, the web, the cloud, those are all invented all pre-1972, back when memory was expensive, computing was expensive, et cetera. They probably won't get us to the next mountain. It's almost like we're standing on Billion Mountain and we're confusing a good view for a short distance, and we think we could just get there from there if we cobble. We're not going to be able to do that. We've probably got to learn new skills. The good news is, get it over with. Then tomorrow morning, take an axe to your couch, burn the house down and run outside, because it is a big world, right? It's like we're fighting over the last scraps of Billion Mountain. MySpace dies, Facebook wins, blah, blah, blah. But the surface area on Trillions is really big. Anything multiplied by a trillion is a big opportunity. So here's the good news. We're trying to teach these things to think, well, we now have not only the Internet of Things, but we have digital manufacturing, which means we can actually change what those things are, and we can evolve them and have them fit us better. And we also have machine learning. Whatever's in Google's self-driving car today is in your shoes tomorrow. That's just Moore's law. Right, and so these
self-walking shoes.
Yeah, who knows? But the thing is, we'll not only put our best genes into these products, but then we're going to have to teach them and then maybe send them off to college, and we don't know what they're going to do, And that's another thing we have to learn is emergence, instead of being able to believe that you can control it all from the top down, because the act of trying to solve a problem changes the problem in this world. So I'm mostly saying these 3 trends are actually slamming into each other inevitably at a high rate. They are creating, in a sense, a primordial soup. Think about the difference between holding a pool cue. It just dangles down, it's a static equilibrium, it settles. That's almost all manufacturing today. Really hard to change the supply chain, really hard to change the factory. So convince people to like what you made, because you can't change what you made. But, and that's used in nature. Doves just fly without flapping. They have this perfect little thing. But then when a hawk comes, they flap away, and that's a dynamic equilibrium. So nature has found a way to play. So balance that pool cue on your finger now. Okay, so I got to move around, I got to sense, I got to have feedback loops, I got to have muscles, and I got to have a brain. We have machine learning, we have sensors and a feedback loop, that's the Internet of Things, and we got like the ability to move. We can 3D print tomorrow morning. You know, Tesla gets a road strike, bursts into flames the next day, all the cars ride 2 or 3 inches up. You know, we have suddenly those 3 primordial elements. The question I have is sort of what's the spark, and how do we put people first? Like that, because it goes back to what you just said. Yeah. We're going to probably have some missteps. You know, but there's a great opportunity if we start kind of letting technology fade in the background and focus on people. How can we give them superpowers?
So I have one last question for you, and I'm kind of like in my head thinking about a lot of great stuff here. Yeah. I mean, how do you take your type of thinking? It's pretty broad, it's very interesting, and how does Autodesk harness that kind of thinking in what they do today?
Well, I think it's really interesting. So as a research fellow, the first month or 2, I was given this kind of great list of like 120 people to talk to all across the organization, and also educators and customers and things like that. And really, you know, what they told me was, you know, we probably have a lot of cool parts of the future already here, but it's hard to see it when you're in the, when you're, you know, the fish doesn't discover, you know, the idea of water, right? And so I just spent a lot of time just exploring, and I found these amazing signals from the future. And if you think about it, Invisalign made 3 million retainers last year, and they were all 3D printed. So they didn't design a product, they designed an authoring tool. We happen to be the biggest authoring tool company in the world for the physical world. They said, this is what we care about, this is the brand integrity of Invisalign, it's got to be clear, et cetera. And then here's a slider. The dentist can slide the slider and say, you know, how tight or loose I want the teeth. And the patient slides the slider and says, this is how many teeth I have in my head. So it's co-created, and it's almost like you designed a species and then you let it evolve in the wild. So very ecological. So I think Autodesk is uniquely positioned because we're doing amazing work in machine intelligence, actually, but we're looking at geometric stuff. We're almost building stuff that can be autocomplete for the physical world, or Shazam for the physical world. We're doing things with machine intelligence around what's called Dreamcatcher, which you set your goals, and then it generates millions of possibilities on those goals, and you cull them like children, and then you have generate a bunch more. You know, it's sort of like evolving a species. And it's only possible now with what's going on. So I think what we're trying to do with Primordial, and that's actually the name of my project, is sort of the next generation is, what's this primordial soup mean? Is take very specific places, like an industry that's going to be affected or disrupted, and say, how would it affect this? So take automotive. It's getting slammed from the left by the Ubers of the world and crowd sharing, and by the right from Elon and DM and Tesla and things like that. So it's under disruption, but it's a $1 trillion industry. And how could we build power tools? So maybe 3 kids in a dorm room could start a car company, like we saw yesterday at DM. You know, that's amazing. How can we enable Kevin and the guys from that world to really democratize and explore and figure out how to do this? And I think now would be the time. So how do we give them power tools in a sense and extend their reach? And that's what we're excited about at Autodesk. And at Maya, I'm excited about that too, because our research has always been around how do we put people first? And this is, you know, use technology but tame it. And so this has just been kind of a joy to experiment. I am scared about it, but I also kind of feel like we could get distracted by that. It's a big opportunity up ahead.
Yeah. Mickey, this has been fascinating. Thank you very much.
Thanks for taking the time.
Thanks.